Imagine standing on a planet where the sky doesn't rain water. It rains diamonds, not metaphorically, not in some poetic sense, real diamonds, falling from the sky. This isn't science fiction. This is what scientists now believe is happening right now, at this very moment, on worlds inside our own solar system. And beyond it, there may be entire planets made almost entirely of this precious stone. The universe is far stranger and far more valuable than we ever imagined. Meet Neptune and Uranus, the forgotten giants of our solar system. Most people think of Jupiter and Saturn when they imagine the outer planets, the big ones, the dramatic ones. But lurking further out, in the cold darkness beyond Saturn, are two worlds that hide one of the most astonishing secrets in all of planetary science. Both Neptune and Uranus are classified as ice giants. Don't let that name fool you. They are not made of ice as we know it. Deep inside these planets, the pressures and temperatures reach levels almost impossible to comprehend. On Neptune, pressures in the interior climb to millions of atmospheres. Temperatures exceed 12,600 degrees Fahrenheit. Under these extreme conditions, something extraordinary happens to carbon. Carbon is everywhere in these planets. It exists in their atmospheres primarily as methane, the same gas that gives Neptune its striking blue color. But as that methane sinks deeper into the planet, the hydrogen atoms get stripped away. What's left is pure carbon. And pure carbon, under millions of atmospheres of pressure, does only one thing: it becomes diamond. Scientists believe these diamonds don't just form, they fall. Like rain, like hail. Diamond crystals, some potentially the size of a fingernail, precipitating downward through the interior of the planet. Sinking, falling, for millions of years. Some researchers have theorized that the largest diamonds may accumulate at the core of these planets, forming a layer of solid diamonds surrounding the rocky center of Neptune and Uranus. A diamond core, possibly larger than the entire planet Earth. For decades, this was just a theory, a beautiful, tantalizing idea. But in recent years, scientists have managed to recreate the conditions inside ice giants right here on Earth, and what they found confirmed the dream. Teams at ESLAC National Accelerator Laboratory in California and the European XFL facility in Germany fired powerful lasers at specially chosen plastics, materials with a carbon-to-hydrogen ratio similar to what exists deep inside Uranus and Neptune. The results were stunning. Under shock pressures that replicated planetary interiors, diamond crystals formed almost instantly. And in 2024, researchers published new findings showing that this diamond formation happens at even lower pressures and temperatures than previously thought. This means diamonds could be forming closer to the surface of these planets than anyone had imagined. But the implications go further than just the diamonds themselves. As these diamond crystals fall through the planet interior, they drag other conductive materials along with them. Scientists now believe this process may actually be responsible for one of the great mysteries of planetary science: the bizarre tilted magnetic fields of both Uranus and Neptune. Unlike Earth, whose magnetic poles roughly align with its rotational poles, Uranus and Neptune have magnetic fields that are wildly offset, tilted by more than 45 degrees. For years, no one could fully explain why. Diamond rain may be part of the answer. But Neptune and Uranus are not the end of this story. 40 light-years from Earth, in the constellation of Cancer, there is a planet that makes diamond rain look modest. It's called 55 Cancri E. Those scientists have given it a more poetic official name: Janssen. Janssen is what astronomers call a super-Earth. It is twice the diameter of our planet, and 8 times more massive. And it orbits its star so closely that a single year on this world lasts just 18 hours. 18 hours. That's how long it takes to complete one full orbit around its sun. Because of this terrifying proximity, the surface temperature on the day side of Janssen reaches approximately 4,900 degrees Fahrenheit. The surface is not rock as we know it. It is likely a churning ocean of molten lava. The James Webb Space Telescope, observing this world in 2024, confirmed that the planet hosts a substantial atmosphere, likely rich in carbon dioxide or carbon monoxide, constantly being replenished by volcanic activity from below. But here is where the story becomes extraordinary. Scientists have proposed that 55 Cancri E. Johnson may be a carbon planet, a world born from a protoplanetary disk, extraordinarily rich in carbon. If the hypothesis is correct, at least 1/3 of this planet's entire mass could be carbon compressed into diamond. We are potentially talking about a diamond layer equivalent to 3 times the mass of the entire Earth. 3 Earth masses of diamond inside a single planet 40 light years away. It should be said, this remains a hypothesis. Later observations have raised questions about the composition of Janssen. The James Webb Space Telescope is still building the picture. But even as a possibility, even as a might be, it changes how we think about what planets can be. Let's take a moment to understand what is actually happening at the atomic level. A diamond is simply carbon, the same carbon that exists in every living thing on Earth. The same carbon in the graphite of a pencil, the same carbon in the CO2 you exhale with every breath. What makes a diamond different from graphite is pressure and heat, light over immense timescales. On Earth, diamonds form roughly 93 miles below the surface, under pressures of around 45,000 to 60,000 atmospheres. It can take billions of years. Inside Neptune or Uranus, the pressure exceeds 1 million atmospheres. The temperatures, though extreme, are paired with pressures so immense that carbon has no choice but to crystallize. The process is violent. It is fast by geological standards, and it produces diamonds that will never see the light of any star. They sink, they fall, they accumulate, possibly for billions of years. And this is not unique to our solar system. Any planet with similar conditions, any ice giant, anywhere in the galaxy, could be experiencing the same phenomenon. With over 5,000 confirmed exoplanets now cataloged, the universe may be producing diamonds on a scale that defies imagination. Step back for a moment and consider the scale of what we're discussing. In our own solar system, there are 2 planets likely producing diamond rain right now. Beyond our solar system, there may be an entire class of carbon worlds, planets where diamond is not a rare gemstone, but the dominant structural material of the planet itself. And if diamond rain shapes the magnetic fields of planets, it is not just an exotic curiosity. It is a fundamental planetary process, as important as the water cycle on Earth, or plate tectonics, or volcanic activity. The universe does not share our sense of value. To the cosmos, a diamond is just carbon in a particular arrangement, no more precious than graphite, no more special than methane. Value is a human invention, and out there, in the cold dark between the stars, diamonds fall like rain. They pile up at the centers of planets. They drift through alien interiors for billions of years. They shape magnetic fields on worlds no human eye has ever seen. We spend our entire lives assigning worth to things: gold, oil, land, power. But the universe operates on a different ledger, entirely. The most valuable substance in human history, the symbol of love, luxury, and permanence, is out there, simply weather. It rains diamonds on Neptune tonight. It has been raining diamonds there for 4 billion years, and it will keep raining long after the last human being has turned to dust. What does that tell us about value? What does that tell us about ourselves? The universe doesn't answer. It just keeps raining.